Welcome to this lesson on evaluating an indefinite integral using substitution. Today, we'll be working on finding the indefinite integral of the square root of 9 minus 4x squared with respect to x. This is a classic problem where we can use trigonometric substitution. When we see a square root with a constant squared minus a variable squared, we'll set the variable to be a constant times sine of theta. Here, we'll let x be 3 halves times sine of theta. Next, let's find the differential dx by taking the derivative of x with respect to theta. The differential of x is 3 halves times cosine of theta. We're going to substitute this into the integral, and also substitute x equals 3 halves sine theta. Substituting these into the integral, it becomes the integral of the square root of 9 minus 4 times the quantity 3 halves sine theta squared times 3 halves cosine theta. When you simplify the expression under the square root, it becomes 9 times the cosine squared of theta. Taking the square root of the 9s and the cosine squared, the expression simplifies further to 3 times the integral of the cosine squared of theta times 3 halves. This then becomes 9 halves times the integral of the cosine squared of theta. Now, remember to integrate the cosine squared of theta using the double angle identity. Cosine squared of theta is 1/2 plus 1/2 times cosine of 2 theta. Using this identity, the integral then becomes 9/4 times the integral of 1 plus cosine of 2 theta. Separate the integral into two parts. 9/4 times the integral of 1 theta plus 9/4 times the integral of cosine of 2 theta. Integrating each term gives us theta plus 1/2 sine of 2 theta. Now, let's reverse the substitution and express the answer in terms of the original variable x. Recall that x equals 3 halves times sine theta. This implies that sine theta equals 2/3 times x. Using this, we can draw the right triangle representing our original trigonometric substitution to help visualize our variables. The hypotenuse is 3, opposite is x, and adjacent is the square root of 9 minus 4x squared. Now, theta is the arcsine of 2/3 times x, and sine of 2 theta is 2 times sine of theta times cosine of theta. Expressing cosine of theta in terms of x from the triangle, and simplifying the expression gives the full antiderivative in terms of x.